Today we're going to be having faculty in focus for the engineering program that we have here at Canadian University, Dubai. We have lots of other faculty in focus on our YouTube channel. This is part of a series. Today I'm here with my coworker Ahmed, who is a student enrollment advisor. Hey Ahmed.
Hi, Greta, how are you?
I'm good. How are you?
Thank you for having
Good.
me.
Thanks for joining. And our guest of honor, Professor Ahmed, who is a professor for the College of Engineering. Hello there.
Hi, good evening, everyone.
Good evening. How are you?
Fine, thank you.
Good.
I think it's a
So,
good evening, good morning, and good afternoon because we
yeah,
have people
wherever
around
you
the
are.
Okay,
world now.
okay.
Exactly,
So
exactly.
it's morning somewhere in the world right now.
Somewhere, exactly. All right, so I do have a question for you, Dr. Ahmed, before we get started with your presentation on the program. My question for you is, what has been your favorite part of your career as an engineer versus as a professor?
I would like to answer this question by sharing a small experience and a dream as well. When I first graduated from high school, I wanted to be a mechanical engineer. I wanted really to join electrical engineer, only mechanical. I had this passion on automotive cars when I was young. And I was doing, when I was 18 years old, I was doing, trying to fix cars and helping my parents to work on the car by hands-on practically. When I was searching for a university, at that time I couldn't find a university who offer mechanical engineering except for marine mechanical, which I really didn't want to join. That's why I decided to go to electrical engineering. Then after graduation, I wanted to have two achievements. First one, I wanted to have my own company as a business, as an entrepreneur. And then second, I wanted to be a lecturer. I didn't think at that time that I would reach to be a faculty member, a professor at a university. I was not dreaming about having a master or a PhD. All what I wanted is just to be lab instructor or to work at a university. Then I did both. After 1 year from my graduation, I did both and I failed in one of them. So my company at that time was not really successful. So I said to myself, let's focus then on completing my postgraduate, a master program, and then a PhD program. And I started to have the academic career. And then again, the old dream came back to have my own company, and I did it 2017, I think. So far it's going fine, and I'm just trying to chase my dreams.
I love that. That's so relatable and so inspiring as
Uh,
well. And I think Ahmed and I can both agree that like you never really know where your life is going to end up taking you. You think you have an idea when you're 17, 18-year-old kid, just getting out of high school, and you try your best to follow whatever your heart tells you, your gut tells you, your parents tell you, but life always has its own kind of way of
Uh,
putting you where you belong.
I wish if I had what the students are having now. Like for example, now we teach students 4 courses of entrepreneur and innovations, which really help them into how to think like an entrepreneur, how to start their own business, how to solve problems, how to calculate the budget, the break-even points. They do cost analysis. We didn't have all this. Now we are teaching this here at CUD, these 4 courses of innovation and entrepreneurial skills, where students can have some experience into becoming a entrepreneurs instead of just becoming an employee.
mhm.
Yeah,
That's amazing. That's really amazing. I think it's really important for students to
yeah,
get a well-rounded education,
exactly.
because sometimes you don't even know what you're interested in until it's right in front of your face. Yeah. Awesome. Well, you've done us the liberty of preparing a presentation for today. So would you mind sharing your screen so we can watch that?
Yes.
Thank you.
Yeah, give me a minute, please. Can you see the sharing?
Yeah.
Looks good.
Okay, hi everyone again. I'm not gonna say good evening. Just hi everyone. My name is Dr. Ahmed Al-Gindi. I'm a faculty member in the electrical engineering. Welcome and thank you for joining the faculty in focus presentation for electrical engineering. We have throughout our presentation, we will have a few topics to discuss related to faculty structure, program offering, profiles of our professors, and some of the trends in electrical engineering, accreditation, and local and international recognition of CUD transferred to Canada. And I'm going to take you also through samples of our student projects and research articles that they are doing and the competition that they have been participating in and winning in the last few years. Faculty of Engineering, Applied Science and Technology has two departments, Department of Electrical Engineering and Department of Computer Engineering and Computational Sciences. Today's presentation will focus on electrical engineering, as I've mentioned, including programs, career opportunities, projects, and latest trends. Under the Department of Electrical Engineering, we have 3 programs. Each program consists of 138 credit hours. This is a 4 years duration program. The first program is Bachelor of Science in Electrical Engineering, major in electronics. The program includes analog circuits, digital electronics, consumer electronics, embedded systems, and power electronics. These are some of the hot topics in this program. The second one is Bachelor of Science in Mechatronics. You will be introduced to issues like design of mechatronic system. Mechatronics is an abbreviation for mechanical electronics. So you will be having a mechanical part working along with the electrical part. So you will have more opportunities to work in the industrial, medical fields, defense robots, systems and instrumentation, and automotives as well. Finally, the third program that we have for electrical engineering is telecommunication. This program concerns more about design and implementation of telecommunication system that deals with data transmission, voice transmission or video, wireless signals, optical networks, satellite imaging and satellite communications. So these are the topics under this program. As I've mentioned, all the programs will have 4 years of study and each of them is 138 credit hours. In order to make it easy for our students, we basically, I just wanted to show you a sample of our study plan. So we've created a visual study plan. This visual study plan is given to students by the academic advisor at first semester. It will help them to track their academic progression and also course offering during the 4 years. If you can see, the arrows in the study plan represents the sequence that students need to follow to complete the major. For example, here, digital logic. You must register digital logic in semester 1 before computer network fundamentals in the second semester. So this is just a quick brief on the study plan and how we do things internally after joining. I would like also to mention that we have 4 other programs, which is in the computer science and computational sciences department. These are computer and network engineering technology. We have also Bachelor of Science in Computer Science and Bachelor of Science in Cybersecurity and Software Design. The computer science programs are 128 credit hours in 4 years, and the computer and network engineering technology is 132 credit hours in 4 years. Now, let me introduce you to our faculty member. In fact, and without any shade of a doubt, we have highly qualified and experienced faculty, which I consider personally the greatest asset of the Faculty of Engineering at CUD. They have outstanding educators background, research background, and some of them also are having a business and industrial background. And this, of course, contributes to overall professional and personal growth of our students at CUD. We have a total of 11 faculty members in both departments, and let me start by Dr. Sharif. Dr. Sharif is our dean. He has a PhD in electrical and computer engineering from Canada. And then we have Dr. Ziad. He have a PhD in electrical electronics from Canada as well. Myself, Dr. Ahmed, I have a PhD in electrical and communication engineering from United Kingdom. We have also Dr. Saeed Al-Nafar. He has a PhD in computer science from Queen's University. We have Dr. Tamer. He has a PhD in electrical and computer engineering from Canada. And we have Dr. Adel. He has a PhD in computer engineering networking from Japan. We have Dr. Rita, computer engineering, PhD in computer engineering, specialized in artificial intelligence from France. And Dr. Ziad, he has a PhD in mathematics from USA. Finally, Mr. Omar, he has a PhD, he has a master's degree in communication engineering from Malaysia.
Dr. Ahmed, did you memorize all that, or you are reading?
I was reading from the
okay
from the names
it's
here.
a lot of information. it's a lot that's very impressive though.
Okay, let me now, guys, take you through some of the top trends in electrical engineering. This is not all of them. It's only the, let's say, the top ones. And the applications or the areas where we can consider that hot topics right now. So we have robotics, we have drones, we have autonomous cars, energy storage and batteries usage, and smart grid, Internet of Things. These are some of the major trends in electrical engineering. Let me now, I want to go through some of these, some of them. I'm gonna just explain a few of it quickly. Like, let's have a look to energy storage and batteries usage in general. You know, guys, that everyone is now speaking about sources for sustainable energy. And wind and solar powers are excellent sources for sustainable energy in general. But the problem is these sources are not always there. You can only save, or you can only use solar power when you have a sunshine. You can use the wind when there is a wind. I mean, you can store you can use windmill to store the energies. Then you have two things. You need a storage, a good storage, to save the sources, to save the energy that come from the sources of sustainable energy. So one of the trends in electrical engineering is to design better energy storage that can really help. And I think, I'm sure that companies like Tesla will keep an eye on the latest innovation in energy storage. So these are one of the things that electrical engineering are doing. We have also trends in, I would like to mention also Internet of Things. I'm not going to mention all of them in here. I'm going to go next to mention Internet of Things. I mentioned drones, but I'm going to mention this in briefly. So Internet of Things as a concept basically is to, sorry, it's this one. It's to connect any device through the internet. Your coffee maker, your washing machine, your headphones, your car. So imagine you are going into the way to a meeting at morning, and then there is an accident by a chance. Then your car will tell you which route you need to take to avoid the traffic, because it's connected. When I say it's connected, it means IoT, Internet of Things. Things means anything. We take it and we connect it to the internet. Imagine further that because you have been delayed, your email or your calendar will send a notification to your boss at work saying that you've missed, or you are missing a meeting because there is an accident on the road. Imagine also your alarm is connected to the coffee maker, where if you put the alarm at 9 a.m. or 8 a.m., then the coffee will start to prepare directly without you interfere. It's gonna trigger the coffee maker, and then the coffee maker by itself will trigger your toaster to prepare the morning waffles, for example. So all these possible options through Internet of Things. And again, electrical engineers are the ones who are being able to design all this. Now, what is smart grid basically? We have been for few years consumers for electrical power. We consume. That's why monthly we pay bills for electrical powers consumptions. But what if we, as an individual, we also generate powers? We generate power by, for example, putting a photovoltaic cells on the top of your house, and instead of being a consumer, you will be a power generator. But you need to connect this to the infrastructure where you can later on sell your power to wherever you want. So through also Internet of Things and smart grid with power generation, you will be able to easily control your power sources. So this is how it goes. Drones, we can see now that drones are almost everywhere. And I'm going to show you next that the number of shipments for the drones are being really increased almost to double and triple from 2019 to 2000 and the future till 2023. The numbers and the expectation for the numbers to be increased is really high. Drones is really effective and becoming more required in sectors like military, commercial, personal, even individuals are using drones, and in future technologies. I'm gonna go back to this in details. Robotics are everywhere. Robotics are everywhere. Many of us, when I ask even my students, sometimes they think that robots are only the one here in the picture that you can see. This is the robot. The thing that looks like a human with arms, legs, and brain or whatsoever. But basically, robots are anything that facilitate and make it easier for us to achieve a task. Your car is a robot. Your car, you will go to your work in 10 minutes. Imagine yourself without your car. You will use a bicycle or you will go walking. Then instead of 10 minutes driving, you will need an hour. So now, because your car is a robot and it made your life easy, it made you achieve things faster and easier, we call it robotics. The elevator is a robot. The escalator that you are using inside the malls are robots as well, escalators. And many things are, around us is robots. So going to other trends, something like autonomous cars or connected cars. I think you have recently seen Tesla and some hybrid cars. That hybrid cars is having an energy storage because it can use a battery or it can work by gasoline. Autonomous cars, the cars that can drive itself. But for autonomous cars to be able to drive itself, then it needs to be again connected, which will take us again to Internet of Things. If you look to the picture here, I'm sure one of them will be cars or automotive. Okay, this is the autonomous cars. Now, I'm going to take just one. See, we have how many trends here? 1, 2, 3, 4. 6 trends. So let's just take one of them, and this one trend will tell us how many career opportunities you can have and how many different sectors you can work in just by having one trend or by only working in one application under electrical engineering. Look to the Internet of Things. You can have 8 different industries. You can use Internet of Things in for smart homes. You can use it for machine-to-machine communication, like Dubai Metro. The metro is a driverless. There is no driver in Dubai Metro. If you've been ever in the first car on the Dubai Metro, it's machine-to-machine communication. There is a control room that controls the metro itself remotely. It controls it remotely. It means that communications is involved here. We cannot split. I cannot say that communication engineering is working only in, let's say, networking or satellite communications. It's everywhere. Electrical engineering also is everywhere. Mechanical engineering is everywhere. So part of any project you do, you will find 3 of them, and I'm going to show you samples later on. So machine-to-machine communication, automotive. So again, you need car to infrastructure communication. You need to connect your car to the internet, maybe to prevent accidents. Maybe cars can communicate with each other to avoid accidents. This is Internet, again, of Things. You can work also in the agriculture sector. You can do crop management or soil analysis by having Internet of Things technologies in your sector, which is basically the agriculture, if you are working there. If you are working in as an electrical engineer in the military sector, then you will have a threat analysis, you will have situational awareness, and you will have drones as well. See, it's all connected. One of our students' projects was security, border security. They have been using 2 drones to cover area of 10 kilometers. I'm going to explain the project later on. And also a field of medical, industry, Internet of Things in medical field, and environmental, retail, inventory control, and focused marketing. This is one of the trends. And also, let's have a look to the number of drones shipment that I have mentioned earlier. Basically drones are becoming really valuable. The reason is it has work efficiency. increased productivity, decreasing the workload, production cost will be also reduced, improved accuracy, of course, security issues. This will be resolved by using drones. So that's why we can see clearly from 2019 to 2023, 12.9 thousands drones have been shipped in 2019, and then 2022 it's doubled. The number is doubled to 24, and then again almost doubled to 44, and then to 75 and 122 expectations for 2022 and 2023. Now, it's so simple now, and I think it's becoming clear. If you can see that in one of the trends or in one of the applications like IoT, there are several sectors, then there are also several industries. Then graduates from electrical or with electrical engineering degree can choose one of these industries: aerospace, automotive, construction, defense, electronics, fast-moving consumers, marine, metals and materials, oil and gas, power generation, utilities, and alternative careers. I'm going to go through some of them, not all of them, but you can read about it online if you want to have one specific industry, if you are interested in. What I'm trying to show you that electrical engineering is really a multidisciplinary field of study in general, and it's all connected. It's all connected to even different fields of industry.
So can I ask something?
Yes.
Related to this part?
Yeah.
So I received many inquiries from the students that they are interested to proceed or to work in the AI industry. So how far this degree can help them, and if they want to go later on for a master to AI in AI, how would they eligible to proceed a master in AI after graduating from electrical engineering?
100% yes. Electrical engineering is the core of all studies. Let me just jump here to show you some of the engineering projects that have been using machine learning, and machine learning is a track under AI. Okay, so you have our engineering here. This is one of the projects. They designed a robot arm. Okay, with machine learning capabilities. It means what? It means that you want the robot arm to be learning from what tasks that it's doing, and basically achieve and later on making tasks without error, without depending on a human. So it will have learning capabilities like us. So artificial intelligence and machine learning, if we look into the definition, it's basically devices can think humanly, or devices that can think like human. So if you are an electrical engineer and you design a robot, this robot on the left side, you want it to work, you want it to act like a human. So which is better? To understand how to design the robot from scratch, its mechanical part, its electronics part, to understand how it communicates. Then after that, you integrate AI algorithms into your device. So basically, you are building it from scratch. You will have the full umbrella of building a fully functional AI robot. Students who have, let's say, those who are studying only IT or fields related to programming in AI only, they are always missing a part. They are always missing the hardware part. They are missing how to design. They don't understand how to connect this to which communication protocol that they will be using to make the robot work. They will have a plus. So electrical engineering students, for sure, can work easily and can continue easily their post-graduate program in AI, in mechanical, in security, in networking. It's the core of all the technical and science education is the engineering. I made it clear, Ahmed?
Yes,
Did I
Dr.
answer your question?
100%. Yeah,
Oh,
thank you so much.
okay. So as I said again, there is no one measure for electrical engineering. Like for those who are working in automotive, for example, they will have to understand things related to security. They will understand things related to control units for the car engine. They will understand interior and exterior lighting, air conditioning, safety systems. Someone may tell me how is it related? How is it related that the engine automotive is connected to electrical engineering? Okay, the car engine is a mechanical part. It has gears. It's mechanical synchronized part that needs to move smoothly and connect with each other. This is a mechanical part. And if you've noticed, all the new cars now are equipped with control units that controls the mechanical part. Means electrical engineering needs to design the control points or control modules along with the mechanical parts. So graduates in electrical engineering who work on automotive, they will be able to design or work with all these areas. Start and stop technology, braking systems, movement of the seats, heating, cooling. This is all electrical parts that needs an electrical engineers to design them and to even to make sure that it will be in a safe manner where later on customers or humans, when they interact with these designed items, they will be able to, or systems, they will be able to utilize it easily. Some other sectors like built-in, built consumable environment, where is it? Constructions, defense, let's take the defense. For defense, you will be able to develop hardware and software systems. You will make sure that your systems will be able to work with air, sea, land in an open environment. So that's why it's a bit of complex products. You will involve also simulation, and there are a lot of simulation and software, let's say software systems that simulate and create a proper data analysis for the engineers. One of the last thing here I kept it's which is alternative careers. What is that? Someone sometimes asks me, what if I'm an electrical engineer and I want to move on to work in, let's say, web developer, as a web developer? We know that web developers are one of the applications in those who are studying IT, information technology. Can an electrical engineer do this? Yes, you can. That's why there is a field or a career that called, there is an opportunity here to be an alternative, a careers where you can just, for example, learn how to do web development and work as a web developer. You can work for those who doesn't like. Women in engineering are really becoming a hot topic, and due to some limitations, sometimes they would like to have an alternate career by working as a school teacher in ICT fields, programming, teach younger kids programming, and so on. These are also areas or opportunities for electrical engineering. Now let's move to accreditation and transfer options. all our programs in engineering are have been accredited by the Ministry of Education in United Arab Emirates. And for transfer options, you can choose to stay 2 years at CUD and then move 2 years to Canada, or 1+3. You can choose to stay 1 year here and then move. I would like also to mention that CUD is ranked in top 2% in QS Global overall ranking. And this is between, when we say 2%, it's between 600 and 650. And it's ranked top 4 universities in United Arab Emirates. QS is an abbreviation for Quacquarelli Simons. It was developed by a British company in 1990, and it's being used now by all university. It's an annual publication of a university ranking. Now, for transfer to Canada, as I said, students might choose to complete their studies at CUD or transfer. You may choose one of the options, 3+1 or 2+2. You can also use, by the way, this interactive map is available on our website. So you can visit CUD website. It's here. It's on the slide down here, www.cud.ac.ae. You can find the interactive map. The interactive map is basically helping helping students who would like to find a study options in Canada and find a university. So the highlights here in the dots in red color here is showing the universities that you might be transferring to. Now, next, I'm going to move to what we do inside the Faculty of Engineering. I will show samples of our student projects, and also student engagement is really important, because one of the really important learning method is learning by doing. So you need to engage, you need to commit to work in different projects, you need to engage to extracurricular activities in order to achieve proper learning by doing, and also research. So as I said, at CUD in engineering, we have latest technologies, state-of-the-art campus, laboratories, qualified faculty members, local and regional recognition, multicultural students community. Now, add to all this learning by doing, then engineering graduates will be ready to hit the ground. Why we are trying as much as we can to engage students in different activities? Because I want students to be jobs ready. I want you to graduate to quickly have an outstanding opportunity for work placement and research. One of the projects that our students have worked in previously is the it's wireless ROV project. It's basically what we call robotics underwater. So this project was designed 2 years ago, I think 1 year ago, by some of the communication engineering students. They were trying to develop a low-cost solution to operate the submarine that you see here. We already have this submarine here at CUD. They were trying to find a solution to operate it wirelessly or semi-wirelessly. Okay, it comes with a cable, so we don't want this device like this. Do you see the cable here? We don't want this cable. So what we are trying to do is to operate it wirelessly. But someone might tell me, already submarines are going underwater, and first of all, there is a crew who is driving the submarine itself. And if there is some other options like sonar modems, you can underwater signal. This is what communication engineers are concerned in now. Signals, voice, videos are not easily to go under. They don't go underwater. You cannot communicate. Like now, I am having my mobile with wireless signals. It's connected to the internet, okay, wirelessly through the air. But underwater, it will not work. So submarines are having another problem underwater. They can only use sonar modems. And during their research, sonar modems are really expensive. Good ones might reach up to $10,000 for only one modem. Of course, depending on the range of the communication that they need in the project. So what they were trying to do in this project to add a module on the top. So this module will be exposed to the air, and while the submarine will be down. This is one solution. The other solution, which is future improvement, they didn't do it. They've done only the semi wireless solution. The other solution is you as an electrical engineer, you design the sonar modem itself. You design it by itself. Components are available in the market. It will cost you few dollars. You buy the components and you design it yourself instead of buying it ready. We have already mentioned the robot arm. I want to keep some minutes at the end for the questions. This is the CubeSat. CubeSat project is basically it's basically a small satellite. Students have designed it. It was last semester. The satellite is equipped with a video and picture modules. It can basically take a picture or video and it can collect data. It's of course less cost compared to big satellites. And it has sensors to communicate with the surrounding environment and transmit data to a control room for data analysis. This is this project. And this is the project for the drones that I have mentioned. So basically, precision landing is really important. What the students wanted to do, they were using 2 drones to cover an area of 10 kilometers for borders security. So what they want, they want to do it autonomously. They don't want any human interaction. So they want the drone to land in the charging station by itself to charge while the other drone is taking over the security. It will record the specific line for security, and then when the battery is about to die, the drone will autonomously land to recharge, and then there will be a swapping between the 2 drones. Of course, they have used Python programming, which again being used in artificial intelligence, and it's being used in cybersecurity. Python programming is a full it's a programming platform that can integrate different applications. Because of that, we have also given our students a drone programming workshop internally by our faculty member in order to help them, because if you can see here, normal programming is different from drones programming. Drones programming will involve commands that you can see only related to drones. Again, some of the projects which is related to connected autonomous cars, we are designing it here. You can see the design in a small scale, and we are doing the testing on this field. You will see the field here. This is the field. So the field, we have the field here in CUD, and they designed this car, and we put 3 cars on the start point. They need to move all the way till the end of the track here without hitting each other autonomously and without hitting the obstacles here in red color. These are samples of our projects. Also, now coming to the engagement part, we are motivating our students and supervising students here to participate in on many competitions like IEEE, Think Science, Huawei competitions. At CUD, we have a dedicated innovation week at CUD. We have WITX conference and some other many other competitions. One of the competitions is again IEEE competition for autonomous vehicles. So basically, they have to improve and design this vehicle. That's why we are teaching them how to do it here. And if you can see, it has sensors, it has communications. Designing the car and connecting the motors and the gears is mechanical. Building on the circuit and the wires and the sensors is electrical or electronics. And then connecting the cars to the internet and making sure that the cars are not hitting each other, which we call connected car, is communication. See, in one project, you have 3 fields of study in one project that you can improve or empower your skills. There is also a competition by Mohammed bin Rashid Space Center to basically design a small satellite system. I will show you some of our winners. So students here, they won VIX. It's a robotics competition. And they were able to beat students from all over from Middle East and North Africa, and they qualifies to for the World Championship at USA. You can find this information on our website. This is also another achievement by our students. They won the 2nd engineering design competition in 2019. And this is one of the also robotics competitions. Our students scored the 2nd prize on the Gulf robotics competition. I would like also to say that faculty student research is really one of our focus. We work a lot with the students in a research to write research articles. Of course, writing research articles is a bit is not easy. You need to do a literature review, and you need to make sure that you write the design methods, the abstract. So I mean, by doing it, you learn, and this is a good preparation for those students who want later on to register master or PhD programs. Finally, if you have any questions, you can visit our website or send email to registration, or you can contact me personally on this is my phone number here. You can WhatsApp me or contact me. I am happy to answer any of your questions. Thank you.
It's very nice, Dr. Ahmed, and thank you for sharing your number also. It says a lot about our professors, by the way. This is the thing that I'm proud of. Like we, as it's Canadian University, we always have an open door policy where the student can just book a meeting with a professor and just meet him. And it's very easy to meet professors. It's not like other places where it's very hard to meet your professor. So thank you very much for sharing this, and thank you for your informative presentation. Greta, do you want to shoot? Do you want to start?
That was so great. Thank you so much for sharing all that. I am not much of a science or math or electronics person, but I feel like that presentation could have inspired anybody to get their hands down, and it's so applicable to everyday life, everything from AI to it really got me with the waffles when you mentioned the waffles in the morning, having the internet involved with your toaster and everything. Ahmed, do we have any questions from our attendees today?
There is a question, Dr. Ahmed, what advice you would share with the freshmen, because they are confused, they don't know what to do, what kind of a laptop they would bring. We kind of get these questions. So what would be your advice?
I always advise even our students to take it step by step. they come first to CD. They meet the faculty members and they look to our programs. If they don't know where to enroll and what to enroll, I'll be able to help them and assist them to understand exactly what they like. If they like to work more into hardware, if they like to work less, let's say in programming. So I will be able to help them. And for the preparation for the first year, I just want them to first join, meet the faculty, get to understand what is the program requirement, because there are many requirements that they need to be familiar with before just directly hitting the road of buying and these type of things, Ahmed.
All right. Yeah, do you have a specific like laptop specifications that they need to bring?
No, not at all. We already have all our laboratories at CUD here is equipped with the up-to-date devices. I recommend not to buy now any laptop that they need to bring at the first year. They just come, and my recommendation for them is to spend the first semester at least using the university resources. Then later on they can get their own.
All right, perfect. And I just want to also give some information about the admissions requirement. So to apply, we will need your high school, grade 10, 11, 12. If you're studying rich curriculum, we'll need O-level, ACE level, and science subjects are a must in the first and actually in grade 11 and grade 12, especially for American and the UAE national curriculum, you need to study physics, and one science subject are a must to start engineering courses here at the university. For those who want to go for IELTS, they either choose IELTS, TOEFL academic, or MSAT English. Plus MSAT math and physics is a must. Correct me, please, Greta, if I'm mistaken.
Did they take off the requirement for the math and physics now?
From engineering?
Yeah.
We're still debating that with the ministry. But the science courses are a must. But for physics, so now for engineering, they have to do mathematics. The score should be 9, MSAT mathematics 900, MSAT physics 800, MSAT Arabic would be 600. So
I
these
would
are
like to
the,
add, Ahmed, that these scores are really easy to achieve.
yes,
Yeah,
100%.
it's not at all difficult. Most of our students who just enrolled now, they have above 1,000, they have 1,000 plus. So it's really easy to achieve. It's not difficult at all.
Yes,
Right.
yes, 100% agree. Ala, we don't have any difficulty so far for the students who registered for the fall. We didn't face any complaint that the exam is hard or something. So everything is going fine. Dr. Ahmed, when the student can go to the major from which semester, and what are they studying in the first 2 semesters?
Usually they study the physics courses, math courses, programming. It's the core courses that prepares them to study the specialized courses later on. I can say that they will study the specialized courses from, let's say, semester 7, 6, 7, 6, 7, and 8. So basically, students from communication, from electronics, from mechatronics will be having same courses for about 2 years and a half. Then in the last 1 year and a half or 3 semesters, they will start to have a dedicated courses. Depends on the major that they have chosen. So
Thank you so much.
if we want to have courses by name, I'll just go to the visual study plan. That's why I mentioned visual study plan, make it really easy for students. So we have a total of 8 semesters and 4 years. First semester, you study courses like English, Digital Logic, Calculus 1, Chemistry, and Programming 1. Then this followed by Programming 2 in the second semester, then Engineering Mechanics, which is basically Physics 1, Calculus 2, Computer Network Fundamentals, English 2, and so on. So these up to here, it's almost common for all the students. Then they start to have a dedicated courses in the last 3 semesters.
Okay.
Great. You can actually, for those of you who are curious, you can actually go to the website and see the study plan for all of the different majors. It has the full 4-year program, and you can even read the course descriptions as well. So if you're kind of, not certain between 2 majors, I always recommend to read the course descriptions and see which one sits best with you.
Yes.
All right, perfect. Well, no further questions.
All right, cool. Well, I guess that wraps things up, unless anybody has any final comments.
All good for me. Thank you so much, Dr.
Thank
Ahmed,
you.
for joining
covered
us
it.
Thank you
today.
so much. Thank
You were a
you.
good help.
Yes, this was very
Most
Thank you.
informative. I really, really appreciate it. You were a great guest of honor. And for those of you who are watching this video, thank you so much for watching. And we have lots of other faculty in focus videos posted on our YouTube channel, all the majors that we're offering here at CUD. So thank you so much for
Thank
joining
you.
us, and everybody have a good day or night or morning or whatever it is.
Thank you very much.
Thank
Thank
All right,
you.
you.
thanks you guys.
Bye-bye.
Goodbye.
Bye.
Bye.
Goodbye.
See you.